Students, very good afternoon to one and all. Can you all able to hear my voice? Am I audible? Good afternoon, Vaishnavi. Good afternoon, Sanika. Good afternoon, Jyoti, Sakshi. Yes. Okay. Yeah, good afternoon, Mahek. Good afternoon. Okay, so we'll continue with the previous year's questions discussion of JEE and NEET today also. Okay. So keep a notebook and a pen with you to solve the questions. So let's go with the first. The first question for today is identify the incorrect statement. Identify the incorrect statement. Suppose statements are given to us, we have to find out the incorrect statement. So take 1 minute to solve this question and try to give me the answer in the chat box. So read out all the options. Option A says that the transition metals and their compounds are known for their catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. Sanika is saying option C. What about others? She is also going for option C. Others. So everybody is going for option C. Okay, let's check. Yes, option C is the correct answer. The oxidation state of chromium in CrO4 2 minus and Cr2O7 2 minus are not the same. So what is the oxidation state of chromium in the first compound? CrO4 2 minus. Yeah, very good. Both of the compounds contains your chromium in +6 oxidation state. They are same. They are same, but they have given they are not same. So that is the incorrect statement. And option A is correct. Okay. All the transition metal can exhibit the catalytic activity due to the given reason. And interstitial compounds are also formed. It is also correct. And option D, Cr2 plus is a strong reducing agent than Fe2 plus in water. It is also correct. Option C is the incorrect statement. Very good. So moving on to the next question. The spin-only magnetic moment value of the most basic oxide of vanadium among V2O3, V2O4 and V2O5 is dash Bohr magneton. So 3 oxides of vanadium are given. We have to find out the most basic oxide from the given 3 oxides of vanadium. And then we have to find out the magnetic moment value for that most basic oxide of vanadium. So first of all, let me know which is the most basic oxide among these 3. Is it V2O3 or V2O4 or V2O5? Which is the most basic oxide? How to find out the most basic oxide? The one which is having the very lowest oxidation number is the most basic oxide among the given 3, right? So in case of V2O3, yeah, very good, Vaishnavi. In V2O3, the oxidation state of vanadium is +3. In V2O4, it is +4. In V2O5, it is +5. So if the oxidation state is less, then the basicity is more. Okay. So the configuration, the V2O3 is the most basic oxide, and we have to find out the spin-only magnetic moment for vanadium in V2O3. So the configuration, the outer electronic configuration for vanadium is 3D, 3 and 4s2. Right? Very good, very good. So vanadium 3 plus means you have to remove 3 electrons. So we will have 3D2 and 4s0. And 3D2 means what is the n value? N value is equal to 2. So mu is equal to root of n into n plus 2. So 2 into 2 plus 2. Yeah, 2 plus 2 is 4. 4 into 2 is 8. Okay, root 8. So root 8, what is the value for root 8? Root 8 can be written as 4 into 2. And if I take 4 out of the root, I will get 2, 2 root 2. And the root 2 value is 1.414. So the final answer will come out to be 2.83. So 2.83, if I approximate this 2.83, then I will get 2.83 approximation is 3, right? If I approximate 2.83, I will get 3. So the nearest integer is 3. Nearest integer is 3. Is it clear to all of you? Able to understand? Okay. Shall I go for the next question? Match the metal ions given in column 1 with the spin magnetic moment of the ions given in column 2. It is also very easy, right? So try to find out the correct match. Cobalt 3 plus, chromium 3 plus, iron 3 plus, and nickel 2 plus. Find out the correct match. Has anyone got the answer? It's very easy, no? So try to write the electronic configuration for all the elements. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay. So for scandium, what is the configuration? It is 3D1 and 4s2. For titanium, it is 3D2, 4s2. So two persons have given option A as the correct answer. Okay, let's check. Then what else we have here? We have cobalt 3 plus. The configuration for cobalt is 3D7 and 4s2. And for chromium, it is 3D5 and 4s1. And for iron, it is 3D6 and 4s2. And for nickel, it is 3D8 and 4s2. Okay, cobalt is in +3 oxidation state. So remove 3 electrons from this. We will have 3D6 configuration. In 3D6, we will have how many unpaired electrons? In 3D6, 1, 2, 3, 4, 5, 6. So we have 4 unpaired electrons. N is equal to 4. So if n is equal to 4, we will get root 24 as the answer. So A goes to 4. Okay. So A is going to 4 in option A and option C. So let's check for the other. Chromium 3 plus. So for chromium 3 plus, remove 3 electrons from chromium. If we remove, we will have 3D3 configuration. So n value will come out to be 3. If n value is equal to 3, then we will have root 15. So chromium 3 plus goes to root 15. So B goes to 5. Yeah, very good. Option A is the correct answer. Option A is the correct answer for this question. You can check for the remaining also. Iron 3 plus, iron 3 plus means you will have 3D5. So 5 means it is root 35. So C will go to 2 and nickel 2 plus will have 3 unpaired electron. So D will go for not 3, 2 unpaired electrons. So if it is 2, then we will have root 8 as the answer. Got it? So D goes to 1. Option A is the correct answer. Very good. So the next question is the difference in oxidation state of chromium in chromate and dichromate salt is. the difference in oxidation state of chromium in chromate and dichromate salt is? Find out the answer. So you need to find out the oxidation state of chromium in both the compounds and you have to take the difference. Chromate and dichromate ion. What is the answer? It's very easy question. What is the formula for chromate ion, my dear students? What is the formula for chromate? It is CrO4 2 minus, right? And dichromate means it is Cr2O7 2 minus. So what is the oxidation state of chromium in both the compounds? Very good, very good. Sarika is getting the answer. So the oxidation state of chromium in both the compound is +6 and +6. So the difference is 0. 6 minus 6 is 0. So the answer is 0. Very good. Answer is 0. Very good, Mahik. It is 0. Good. Okay. So we'll go for the next question. Which one of the following ions exhibits DD transition and paramagnetism as well? Which one of the following ions exhibits DD transition and paramagnetism as well? So which one exhibits the both? DD transition means we should have unpaired electron, and for paramagnetic character also the criteria is we should have unpaired electron. So find out the compound which has unpaired electron. Option B and option C. So what about others? Vaishnavi is giving option D as the answer and Jyoti is Sakshi, they are going for option C. Option D, B or C, say anyone. Okay, so to solve this question, we need to find out the oxidation state. Okay, so the oxidation state of chromium in the first compound is +6 and the chromium 6 plus 6 configuration formula will be 3D 0 and 4 is 0, right? Because the configuration for chromium is 3D 5 and 4 is 1. If all the 6 electrons are lost, then the configuration is 3D 0. So here we don't have d electrons, so this compound cannot have dd transition and paramagnetism. So in the second compound, Cr2O7 2 minus, it is dichromate ion. Again, the configuration is +6. Again, the case is same. Okay, the case is same. So this compound also cannot exhibit. When you go for manganate, permanganate ion, MnO4 minus, what is the oxidation state of manganese? Yeah, it is +7. What is the configuration for manganese? It is 3d5 and 4s2. So we have 7 electrons and all the 7 electrons are lost here. Manganese +7. So what will be the configuration? 3d0 and 4 is 0. We don't have d electrons here also. Okay. And in case of MnO4 2 minus, oxidation state is +6. If it is +6, you have to remove only 6 electrons from here. So manganese +6 configuration will be 3d1 and 4 is 0. So only manganese +6 have Only manganese plus 6. No, my dear, D is not diamagnetic. It has one unpaired electron, right? We have one unpaired electron in D orbital. We have one unpaired electron in D orbital. Okay. So MnO4 minus it is. It is not permanganate. This is manganate ion. Manganate is paramagnetic only. Permanganate only is diamagnetic. Okay. Permanganate is called as diamagnetic. Manganate is paramagnetic. So because of this one unpaired electron, this compound can exhibit DD transition and paramagnetic as well. Got it? So option D is the correct answer. Vaishnavi, clear? Can you able to understand why manganate is paramagnetic? So if a compound is having unpaired electron, then that is paramagnetic in nature. Okay. Yes. For others who gave option C as the answer, Sakshi, Jyoti, and Vaishnavi. So guys, can you are able to understand now why option C is incorrect? Yes. Good. So don't make silly mistakes like this. So these are all very, very easy questions. Okay, which you 4 marks easily. So don't make silly mistakes and lose your marks. So try to be very careful and give the answer. So I'll go for the next question. The value of magnetic quantum number of the outermost electron of zinc plus ion is. So here this question is related to magnetic quantum number. You might have studied about magnetic quantum number in your class 11 of atomic structure lesson. Okay. So in atomic structure lesson, we have this topic. So you can recollect that and find out the answer for this. The outermost electron of zinc plus ion. What is the atomic number for zinc? Can anyone give me the atomic number for zinc? Very good. It is 30. What is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay. So actually after this is the observed configuration, you can interchange this. Okay. So 3d10 and then you can write 4s2. So here if you see the outermost electron of zinc plus ion means we have to remove this one electron. So if I remove this one electron, I will have this everything here. Then at last I will have 3d10 and 4s1. So this is the configuration for zinc plus. Okay. So we are going to talk about this one electron. So what is the magnetic quantum number value for the 4s electron? 4s electron. Since this orbital belongs to S, okay, for S orbital, L value will be equal to 0. Okay, what is L here? L is the azimuthal quantum number. So that value will be going to 0. And the magnetic quantum number is nothing but minus L2 plus L. So this is the formula. L value is already 0. Minus L2 plus L means it is again 0. So M value is equal to 0. Okay, magnetic quantum number value for the outermost electron of zinc plus ion is 0. Clear for all of you? For s orbital, L is equal to 0, and for p orbital, L will be equal to 1, and for d orbital, L will be equal to 2, so, and for f orbital, L will be equal to 3. So since the last electron is present in s orbital, L value is equal to 0, so M value from minus L to plus L is also equal to 0. Yes, good. I'll go for the next question. The spin-only magnetic moment is same for which of the following ions? The spin-only magnetic moment is same for which of the following ions? Find out the answer. Take your time and find out the answer. Very easy question. Option A. Sakshi is going for option A. What about others? Anika is going for option B. You should be very clear in writing the electronic configuration. Then only you'll not make mistakes here in these types of questions. Okay. Vaishnavi's option is A. Any other? Has anyone tried? So the correct answer is option A. Correct answer is option A. Okay, so B and D. So what is the spin only magnetic moment value for titanium 3 plus? What is the value for titanium 3 plus? Titanium configuration is 3d2 and 4s2. So if it loses 3 electrons, we will have only 1 electron. So n value will be equal to 1 for titanium. Okay, clear? For titanium 3 plus, I'm saying. Then if I go for chromium, chromium will have 3d5 and 4s1 configuration. Chromium 2 plus means what I have to do? I have to remove 2 electrons. So I will have n is equal to 4. N value as 4. Yeah. And for manganese, if you see 3d5 and 4s2. Manganese 2 plus means we will remove these 2 electrons and the n value will be equal to 5. Clear? Yeah. And for iron 2 plus, iron, the configuration is 3d6 and 4s2. So iron 2 plus means remove these 2 electrons. And if you fill the electrons, you will have n is equal to 4. Okay. And for scandium, configuration is 3d1 and 4s2. And if we remove all the 3 electrons, we will have n is equal to 0. So n value is same for chromium 2 plus and iron 2 plus. B and D only. Okay. Fine. So we'll go for the next question. The pair of lanthanoid ions which are diamagnetic is. So we have discussed this in the physical characteristics, right, of lanthanoids. So in one of the points I have given this. So I have given 4 ions, except those 4 ions, all others are paramagnetic. So you have to find out the correct answer. Which which pair is diamagnetic? If you know those 4 ions, you can get the answer. You have to remember those 4 ions, you can give me the correct answer within a second. So if you could not recollect those 4 ions, if you did not study, then it is going to be very difficult. So Vaishnavi is going for A. Others? Others? What about others? Vaishnavi, can you give me those four ions? Which among the four lanthanide ions are paramagnetic in nature? Uh, sorry, diamagnetic in nature. Can you tell me those four ions? Yeah, you can type that in the chat box, or you can lanthanum 3 plus. Very good. The second ion is lutetium 3 plus. Very good. The third ion is option A. Yeah, cerium 4 and ytterbium 2 plus. The four ions which are diamagnetic in nature is lanthanum 3 plus, lutetium 3 plus, cerium 4 plus. So these four ions are diamagnetic. So except these four, all others are diamagnetic. Okay. Discuss in the class. Okay. Students, I'm really sorry. So there is some internet connection in my side. Sorry for that. Can you all able to see the screen? My dear students, are you able to see the screen now? Am I audible? Yes. Okay. So sorry for the interruption. Sorry for the interruption, students. So is this question clear of you? Any doubt? Shall we go for the next? Shall we go for the next? Yeah. Okay. This question is repeated. Same thing. Oh, sorry. So take this question, students. The reason for greater range of oxidation states in actinoids is attributed to. The reason for greater range of oxidation states in actinoids is attributed to. Which is the correct answer? The reason for the greater range of oxidation states in actinoids is attributed to. We have studied that screen is not visible. Jyoti, can you able to see the screen? What about others? Students, can you able to see my screen? Yes, yes. Okay, Sakshi, can you able to see now? Okay, fine. So many of you are going for option B. Yeah, we have option B is the correct answer. We have studied, we have studied that the most common oxidation state for lanthanoid is +3 and for actinoids they exhibit variable oxidation state. And I already given the reason that because of the comparable energies of 5f, 6d and 7s orbitals in actinoids, they exhibit the greater range of oxidation state. Okay, they exhibit variable oxidation state. So option B is the correct answer. Okay, because in actinoids, the 5f orbitals only will get filled. Okay, the energy level, energy difference, if you see for these three orbitals, they are more or less same only. So that is the correct answer. So here I'm closing the previous year's questions from the Dev block elements lesson. And I hope you have enjoyed this lesson and have studied and learned many concepts from this lesson. Okay, so today will be the last class for you all. Okay, so after some days only we will start back again. So any doubt for anyone from the D and F block lesson or from the other three lessons which we have studied? No? So I just want to say something before leaving the class. So try to study all the four lessons thoroughly in this vacation. Okay, so this is point number one. What you have to You have to go through and revise all the lessons. If you have missed any of my classes of these four lessons, I already told you, know, go to the highlight to and watch all the videos over there. Take notes from that and then make a note, separate notes from your side and follow that notes and try to revise formulas again and solve as many questions you can. Okay. So what are the four lessons we have studied? Solutions, electrochemistry, chemical kinetics, and D and F flow. So all these four lessons should be thorough and from your side before coming to the next class. Okay. Try to go through the videos and lectures and take the notes and study. This is point number one. Then point number two is you can utilize these time actually can able to hear my voice. Yeah. So the second thing is all of you must go through the JEE papers and NEET papers. Okay. So we have the papers and NEET papers on the internet, and there are many sources from which you can get question papers. So try to solve the 11th class lessons questions and 12th class these four lessons questions from those JEE previous year's paper set and NEET previous year's paper set. Okay, so you can use these times to solve those things. So don't waste your time. Sit and solve the previous year's questions of both the competitive examination and try to revise again and again. And you can use this time to revise your 11th standard concepts also. Okay, so we have 14 lessons in 11th standard, right? So in that point, we have only 10, deleted portion is 10. So you can go through those lessons now Including this, we have 14 lessons. So try to thorough all the 14 lessons this vacation. Got it? So enjoy your vacation. Try to give some info chemistry and go through the things which I have said. So if you want to say anything or if you want to ask anything from your side now, you can ask. Otherwise, we can wrap it up the today's session and meet the next session as soon as possible. Okay. Anything from your side? Nothing. Okay then. Thank you, students. Thank you so much for attending the lecture. Meet you all soon in the next session. Thank you so much. Take care. Take care. Bye bye.